Hey everybody out there, it's Mrs. C, and I am coming to you with a quick video, hopefully, of absolute value. You've already hopefully seen the video on intuition of absolute value, and now you're progressing on to a little bit more of a in-depth practice session, might you say, on absolute value, solving absolute value equations. And so just going to jump into it, and I'll try to talk to you a little bit on the side as we do it, try to clear up some of the common mistakes. And let's get going. Now, just a warning as I'm writing the absolute value of a plus 7 is equal to 15. As I am making up these absolute value equations, the key word here is I'm making them up. And so one thing I know that's probably going to happen when I make up problems is that I get fractional answers. Now, not on this one, but on ones in the future. Bear with me because I'm doing it on purpose. So I've divided my field just like always, and I notice that my absolute value bars are by themselves on the right side, and that's, on the left side. And that's what you want to do here, guys, is you want to always work to isolate the absolute value bars. And you see the bars themselves and whatever's inside them are on the left side, and then there's a number that's not in an absolute value bar on the right side. That's prime condition here for me to do what I need to do. Now, you might say, well, what do you need to do? Well, I got to find out what A is equal to. And if you watched my intuition video, you'd be able to probably give me an idea as to what is one possibility that A could be equal to. And many of you jump right into it and you say, well, A could be equal to, absolutely, A could be equal to 8. Because 8 plus 7 is 15. See, right in here, the quantity inside the bars, 8 plus the 7 equals 15. And what's the absolute value of 15? It's 15. The distance from 0 that 15 is, or how many units 15 is from 0, is 15 spaces. Now, that's not 15 spaces because I'm not going to tell you, make you sit here and watch me make 15 spaces, but that's basically the point, is that is what absolute value is asking you, is to tell it what is its positive distance from 0. And so the answer would be not 15 equals 15, but remember, I was just trying to use my mind as to what would give me the absolute value of 15, and I already know. I know that A would have to be equal to 8. If A was equal to 8, then I would have the quantity of the absolute value of A plus 7 be equal to 15. All right, now let me give you another scenario, because those of you who've watched the video on intuition know there is more to it, right? There's another number that would give me the value, and that other number would be whatever you would have to make A, so that the value of A plus 7 would also give you a negative 15. And the reason why you want to figure out A plus 7 equals negative 15, the reason you'd want that little mini equation is because we have to understand that if the value inside the quantities of these absolute value bars is negative, its distance from 0 is still what? Positive 15. And again, if this is confusing you, I want you to go back and watch my intuition video. And I think my intuition video, because this is the YouTube world, my intuition video is actually on Educreation, so you'll have to find it there. We come back over here to this problem. We have A plus 7 equals a negative 15. If you can't do the math in your head, you just go ahead and follow the math with the algebra. A could also be equal to, what is that? That's 22. Negative 22. So when you add 7 to 15, you get 22. But what we were trying to get is the value of A, so that when I added 7 to it, I'd get negative 15. And why did I want negative 15? Because the absolute value, guys, of negative 15 is, guess how many units from 0? That's right, 15 units from 0. So the answer could also be A is equal to 22, negative 22. Because negative 22, follow me here, plus 7. Different signs, find the difference. Sign of the higher number, right? That would give me a negative 15. And what I just said was, intuition states that the absolute value of negative 15 is equal to 15. And then we have a true statement. We've made our equation true. Now that's using intuition, but some of these problems, guys, can get a little bit trickier than something you want to sit there and try to use your intuition on. So let me just show you the proper process steps to show when you're doing these things from scratch. So let me give you something a little bit different, though. 2 times the absolute value of 3x minus 6 equals 10. You're thinking, whoa, what are you doing to me, Mrs. C? That's not, that's just, what? There's a 3 on my x inside, there's a 2 on the outside, there is craziness going on here. No, there's not craziness going on. We've already gone over how to solve these. That's not the problem. I'm going to shrink, I don't know if I can shrink that down, so I'm going to just raise it up there a little bit. Okay, sorry. I've already taught you how to solve an equation. Now, bear with me, and remember, you were the one who was supposed to have watched the absolute value intuition video. I said in the example before, you need to isolate the absolute value bars. Are the bars, which is everything in here and in here, isolated? Well, no, they're not. There's this 2 on the outside. What's the relationship between a number when it touches an absolute value bar or a parenthesis? It's multiplication. So because the relationship is multiplication, the undoing of the relationship is going to be what? Exactly, division. Now, as much as you may want to distribute, please do not. You cannot distribute into absolute value bars. It is against the rules. Best you're going to be able to do is divide by both sides by 2. That'll cancel out that multiplication relationship and leave us with what we want. The absolute value of 3x minus 6 equal to 5. 10 divided by 2 is 5. Now you've achieved the isolation of the absolute value bars. Here's how you solve an absolute value equation when it looks like this. If you don't want to go guessing numbers that could be the value of x and then timesing them by 3, minusing 6, and hoping you get 5 or negative 5. There is an easier way, I think. It's to break up the problem, the absolute value of 3x minus 6 equals 5, into 2 different equations. Now, in order to do that, I don't want this bar down the side, and I'll show you why. One option is my positive option, and I'm going to give you that in green. I could have the 3x minus 6, this quantity here, give me a positive 5. That way the absolute value of it would be just straight out equal to 5. But there's another option that we talked about, and that's my red option. It's my 3x minus 6 could equal negative 5. And the reason it would equal negative 5 is because as long as what's inside gives me a 5 or a negative 5, its absolute value will make this a true statement, because the absolute value of negative 5 is 5, and that would make this a true statement. So these are the 2 ways that you have to solve the problem. You have to set it equal to its positive self, which it already is, and then you have to set the equation equal to its negative self, which is what we did here. Please note that I did not change any other signs in this problem. The only thing I changed was the value that it was equal to, and that's really important. I see a lot of kids changing more than one sign, like inside the problem, and that's just not going to work. So I'm going to get rid of the original because I do not have room, and I'm just going to show you the working of these 2 problems. And I'm using the color coding, hopefully to get you into the understanding mode of how you have a positive version and a negative version. And so here we go. We would find that if we added the 6, we would have the 3x is equal to 11, divide by 3, and there's our fraction. Now, as much as I keep telling you guys to leave these in fractions, you guys keep giving them to me in decimals, and that's got to stop. So the final answer here is going to be x is equal to 11 thirds, and you're going to leave it like that. Now we're going to go up, we're going to do this other one, And we're going to rewrite it. Well, we aren't, I am. And we'll just do this simple little, these are two-step equations. We have a 3x equal to 1, another fraction, no big deal. And I'll erase that. Oh, that wasn't erased, was it? And then I'll... oh, there's always a glitch, isn't there? X is equal to 1/3. Now, these are my two answers. I always do a quick double check to make sure I didn't screw up any signs. I do not always have a positive and negative value when I'm solving. Oh, that's my alarm. Pay no mind to my alarm. What was I saying? Oh, thank you. I don't always have a positive and negative version. In this case, I wound up having x equal to two positive values. One was 1/3, and the other one was 11/3. Now, if you were to want to graph these on a number line, then you would need to know their decimal equivalents, or at least their mixed number, excuse me, their mixed number equivalents. But right now, I really don't care so much about where they fall on the number line. It doesn't really matter. If you recall, we were just solving an absolute value inequality, equality, excuse me. I don't know if you remember what it was. I believe it was the absolute value of 2 times the absolute value of the 3x minus 6, and then it was equal to 5. So we just found the two values that x could be. Isn't that pretty wild? We found the two values that x could be that would actually make this equation true. And I think that's pretty neat. Now, a check step would be really awesome because in this case, the check step would verify that you did it right. Now, the check step, as bad as it might look, let me see if I can do this. Oh boy. I'm going to erase everything and hope I can do this. Meaning, remember what I just wrote. We had 2 times the absolute value of 3x minus 6, and that was equal to 5. And we said that x could be equal to 1/3 or 11/3. Those were my two options that I thought satisfied the equation. But remember, I made the problem up, so I do feel a little bit nervous about that. I don't want to publish a video and have it be completely wrong. You know I have made mistakes before. So if I plug in the 1/3 here, it should have used maybe a better color. Sorry, I'm having color issues. If I plug in a value here for x, and maybe say make that value equal to this value, then I could evaluate the equation. So it would be 3/1 times 1/3, because that's what x is. In this case, it's 3 times 1/3. Those will cancel out and give me a 1. Then it's the 1 minus 6. See right here? That 1 minus 6 is a -5. Now, I don't recommend you do this check step in your head, but you're with me, so I think we can safely do it together, right? Now, that is equal to a -5. And I'm back. I paused you because, of course, as I stop here to do my check, I see that's not going to actually 2, I'm supposed to multiply by 2. That's not going to give me -5. And then I did realize that my original equation wasn't equal to 5, was it? You remember it. If you go back, it was equal to 10. Because one of my steps, well, my first step, remember, was to undo the multiplying of 2. So I divided both sides by 2. That's where the 5 came from. But if I'm doing my check step, I need to use the original equation. And this is the original equation. So you'll see how things start to make a little bit more sense. That threw me for a second. Okay, here we go. Now, 2 times the absolute value of a -5. Well, you always, no matter whether you're solving them or not, you want to get the absolute value bars kind of by themselves. But in this case of an evaluating, you can find the absolute value of 5. Excuse me, I sneezed. The absolute value, this video is riddled with all kinds of craziness. The absolute value of a -5 is 5, and 2 times 5 is 10. My goodness. I am not stopping. I'm sorry, but it is just going to go the way it goes. Now, in the next case, I want to plug in another value. That other value I'll use a different color. Let's plug in the value with 11/3 this time, and hopefully it goes a little bit better. So, meaning no screw-ups, no sneezing. So we have 3, that's an eraser, we have 3 over 1 times 11/3, and that's minus 6. I'm just showing you the actual, all of the process here. This is what we're evaluating. So these cancel out, right? 3 over 1 times 11 over 3 is going to, those 3's are going to cancel out. It's going to leave me with an 11 minus 6, and then that's times that, and that's equal to that. What's 11 minus 6? Well, 11 minus 6 is equal to 5, right? I believe so. And then what is 5? The absolute value of 5 is 5, so that's an easy one, right? 2 times the absolute value of 5 is 2 times 5. You're asking maybe why aren't I adding or subtracting them? Because it doesn't tell me to add or subtract them. It says 2 times the quantity that's in the absolute value bars, and that's going to give me 10 also. And so that checks out. Woo! All right, let's just try one more without all of my talking and hopefully not too much erasing so that I don't forget anything in my original problem, but I am going to make it up. So let's say we have 3 times the absolute value of 2x plus 6, close absolute value, minus 4 equals, I don't know, 12. I'm doing let's do 11. See if I did that math in my head. If not, I'm going back because I don't want to work with fractions too early. All right, so remember, absolute values isolated by themselves, first isolated by themselves, that is the same thing. Why don't you pause and try that on your own first. Get the absolute value bars by themselves on the left side. Go. All right, if you're staying with me, you want me to do all the work. Thanks a lot. All right, I did my math right because it looks like I'm getting a number that's going to be nice and divisible. So first I'm going to add the 4 to both sides, like I pretty much would in any equation. That's going to give me the 15 on the right, and it's going to give me the 3 times the absolute value of 2x plus 6. All right, next step, get the 3 off. That's a divide by 3. That's the little calculation I was doing. I wanted to make sure the 3 went evenly into the right side. Okay, now I have the absolute value of 2x plus 6 equal to 5 divided by 3. 15 divided by 3 is 5. Gave my answer away. All right, so I have the absolute value of 2x plus 6 equal to 5. Now, this time I'll be a little smarter here. I'm going to erase, but I'm not going to erase the original because I don't want to have to try to remember that thing. And then I'm going to write this answer just underneath it so that I have more room. In future videos, I have found another program which will allow me to increase my space without erasing, and that's going to be really helpful. So that's more to come in the future. So, do you remember the colors I broke this down into? Broke it into a green, and I broke it into a red, and hopefully you remember why I did that. And is this a 5 on the right side again? They're not always 5s, guys. If you make your 2 arrows first, you're probably less likely to forget this step because a lot of students will just put one value, and absolute value has 2 values. You need 2 values, please, unless your answer is 0, and then, there's only one 0. There's not, the absolute value of 0 is 0. There's no negative or positive 0, but I digress. Let's just go ahead and do this. The green version, oops, that's my, it's my alarm again. Okay, and then I'm going to go over here, I'm going to do my red version. Now my red version will be the same as the stuff that's on the inside, 2x plus 6. And then what will be the other side thing? The other thing should be negative 5. Now, I just thought to myself, I bet they're wondering, where did the absolute value bars go? They didn't go anywhere. I'm trying to figure out what this would be equal to that if you plugged in a value for x and times it by 2 and added 6, you would get a positive 5 or a negative 5. That's why these are my two options here, because that's what that is. And the absolute value of either of those will give me a 5. And that's why there's no absolute value bars. I'm working inside the absolute value bars, but I'm not showing them. So if I come over here to my negative 1 and just minus the 6, not my negative 1, but the one that's negative. Anyway, you know what I'm saying. This is supposed to be a 6, by the way. I get 2x minus, I believe that's 11. Yeah, I know, it's a negative 11. I got it. I think I got it. You guys just watch me. And I got a negative. Write that up here because I'm out of space. Negative 11 halves on this side. And then let me go to my green. And then I'm minusing the 6. Then I have the 2x equals negative 1. I'm trying to divide by 2. It won't let me. Come on. Ugh. I'm off the page. Okay. I'm dividing by 2, even though you can't see it. So then x is equal to negative 1/2. Sorry about the loss of page there. You may be asking, are they always, Mrs. Crusoe, are they always equal to fractions? No, they're not always equal to fractions. Why are we getting fractions? Because I'm making them up. And when I make things up, yeah, that kind of happens a lot. Now, I've got two values. The solutions are what are boxed. The value of what x is right here, this x, is equal to negative 1/2. That's an option, but also it could be equal to negative 11 halves. And if we did the evaluation step, let's just quickly, I don't want to make this video any longer than it already is. If you plug in the value of a negative 1/2 here, it's not too hard to do mental math with a half. You work with me for a minute here. It would be x times 2, so it would be negative 1/2 times 2. Well, half of 2 is 1, but it would be a negative 1. So this value would be negative 1 plus 6 would be 5. So inside, that's what we wanted. Remember, we wanted this to be 5. The absolute value of 5 times 3 is 15. 15 minus 4 is 11, and that checks out. And you would have to hope that the negative 11 halves works also. So when we times the 11 halves and it's negative, so my value is going to be negative. After I do this, the 2's cancel out, and it leaves me with a negative 11. Negative 11 plus 6 is going to give me a negative 5. So that's going to give me negative 5. And then, of course, negative 5 times 3 is a negative 15. Negative 5, excuse me, the absolute value of negative 5 is 5, and then the rest of it goes the same way. 5 times 3 is 15, minus 4 gives me 11. Oh my goodness, guys, I hope this gave you a little clarity on a lot of things. I hope it gave you more clarity on just what absolute value is, and then an idea, because I gave you this one in yellow. This is as saucy as I will make these absolute value problems. So I'm hoping I've exposed you to the process enough so that you have a pretty good understanding of how to solve these, and where you can go for practice, because that's what you need is back in class. And in class, that's where we'll practice this skill. May I recommend CUDA for practice? Now, they don't have really hard ones. If you go to the CUDA software for absolute value, the skill, again, is absolute value, ABS value. And you are solving equations. So you're solving absolute value equations. Practice on CUDA, and I found a ton of practice on the internet, but you got to kind of be picky, because you'll see graphing absolute values, you'll find evaluating absolute values. You're looking for solving absolute value equations. That's what you want to do your searches for when you're looking for practice. That's it for today, guys. Hope I kept you entertained, and I'll see you on the flip side. Peace.